Today's video is going to be about Ohm's law. So Ohm's law is a law in physics, engineering, connecting different electrical characteristics like the voltage measured in volts, symbol is V, the current measured in amperes, the symbol is A, and the resistance measured in ohms, and the symbol is the Greek letter omega, the capital letter omega. A quick and easy way to remember Ohm's law is this little symbol. Sometimes you might find it in the form of a circle. And even though those three formulas here to the right can be found algebraically fairly easily, let me show you how this symbol is used. For example, if you're trying to find the voltage in a circuit, you can simply put your finger over the V, and you see that V is equal to R times I. On the other hand, you might want to find the resistance, in which case put your finger over the R, and you see that it's going to be equal to V over I. And lastly, if you want to find the current I, you put your finger over it, and you see that I is equal to V over R, as shown in the formula right here. Okay, so based on that little diagram, you have three formulas available to use depending on what you're looking for: the voltage, the resistance, or the current in your circuit. Okay, so let me show you a very simple little example right here. Okay, so we have here little schematics, little diagram of a circuit, whereas we have the electromotrice force, which is essentially the source voltage from the battery, which I set as 9 volts. Okay. This little symbol right here is the symbol for a battery, and we have here the positive terminal, and right here the negative terminal. Little minus, little plus. This here is a single cell battery. Those lines right here are just wires, and this is the symbol right here for a resistor that I called R1. Now, this is a resistor, but really what matters is the resistance of it. And this is used in linear applications like this one to represent any kind of resistance. This could be a photo resistance. The symbol would be slightly different, but it could be just a little light bulb. It could be anything. Okay. This I1 is the current leaving the battery going through the resistor and completing the circuit. Now, the arrow is going to go from the positive side toward the negative side. It's a convention. We're just using it in this class. VR1 right here represents the voltage dropped by the resistance R1, and I show it as a little arrow going toward the positive side of the battery. Do we need to draw this? At our level, not really, but later on in more advanced electrical analysis classes, or when we do more difficult circuits, it might be useful. So I'm just putting it there, even though the little arrow, even though I'm not going to use it. Okay? So for this example, what do we have? A resistance R1, which is equal to 220 ohms, and I'm looking to find the current in this entire circuit, granted that we have a battery that supplies 9 volts. So since I want the current, I'm going to use this formula, the one that we have right here. I'm going to rewrite it. I would advise you to also start by writing your formulas when you solve problems. So it's going to be I1 equal VR1 over R1. Now, granted, we don't really know what VR1 is. I wrote 9 volt because of another little electric law that is called Kirchhoff's voltage law. And Kirchhoff's voltage law says that the voltage of the sources, which are all the batteries you might have in a circuit, is equal to the voltage of the loads. Basically, the loads is a generic term for everything that uses electricity in a circuit. Okay? So you can think of the sources as food, and as the loads as what consumes the food. So all the food that is produced is consumed by, in this case, the resistance R1. So VR1 is equal to 9 volts. Okay? So if you go back to the formula, you have 9 volts right here. You have 220 ohm right here for the resistance, which means you have 0.409 amps or 409 milliamps. Okay? Use your calculator. You do that. 9 divided by 220 equal. There you go. Okay. I hope this was helpful, and I'll see you in another video.